simple rule we're going to apply. It's called the law of reflection. And there's only one thing you need to know, and that is all images are always measured not from the mirror itself, but this thing called the normal line. The law of reflection simply states that the angle of incidence is equal to the angle of reflection. Are you guys familiar with this Greek letter with the line through it? It is a Greek letter. Anybody know? Theta just means angle. So the angle of incidence, the incoming light, is equal to the angle of reflection. And in real life, you actually kind of already know this every time you look in a mirror, or if you play sports. So a lot of times in basketball, if you want to get the ball to your teammate, right, you can't necessarily just pass it through the airways because you're going to worry about an opposing defender blocking the ball. So you do a bounce pass, right? And you already kind of know that if you bounce the ball in at a 45-degree angle at the ground, assuming you don't put any spin on it, how does it bounce out? At a 45-degree angle. If you come in like kind of sharp, like at a 30-degree angle, it'll come out at a 30-degree angle. 60 degrees, 60 degrees, etc. So the tricky thing is all rays are not referenced from the mirror itself, from the surface of the mirror, but this perpendicular line called the normal line. Normal is just a fancy geometric term for perpendicular. The reason why is if you have a curved mirror, you don't have a way to reference that angle unless you can draw in a tangent line and construct a perpendicular. So that's why we reference it from the normal, which we'll look at in a second. So on a windy day, you don't get an image off a lake because the water is what we call a diffuse reflector. It scatters the light. But if it's calm, it's a smooth surface, you get even reflections. That's why you can get an image. Because the rays bounce evenly, symmetrically, your brain puts together what's called a specular reflection. You get a virtual image that's formed there.